Hi, welcome back for another 5 Caillou challenge. This one's called Josephus Permutation. This problem takes its name by arguably the most important event in the life of the ancient historian Josephus. According to his tale, he and his 40 soldiers were trapped in a cave by the Romans during a siege. Refusing to surrender to the enemy, they instead opted for mass suicide with a twist. They formed a circle and proceeded to kill one man every 3 until one last man was left, and that it was supposed to kill himself to end the act. Well, Josephus and another man were the last 2, and as we now know every detail of the story, you may have correctly guessed that they didn't exactly follow through the original idea. You are now to create a function that returns a Josephus permutation, taking as parameters the initial array list of items to be permuted as if they were in a circle, and count it out every k places until none remained. Tips and notes: it helps to start counting from 1 up to n instead of the usual range 0 to n minus 1. K will always be greater than or equal to 1. For example, with the array, the integers 1 through 7, and a k value of 3, the function should act this way. You have your initial sequence, then you count 3. 1, 2, 3. You land on the element 3. And so notice how it's counted out, and you're left with 1, 2, 4, 5, 6. Now imagine my cursor is right between 2 and 4. Count off 3 again. You get to 4, 5, and then 6. So notice 6 is removed. We're between 5 and 7, so you count again. You hit 7, go to the start, 1, 2. Now 2 is pulled out. Count again, 4, 5, 7. You landed on 7, it's pulled out. You were at the end, so you start at the beginning, 1, 4, 5. 5 is pulled out. Again, you're at the end, so you're going to count 3, 1, 4, 1. So you're going to remove the 1. Finally, you're just left with 4, and the last person kills themselves. So 4 goes away, and then you're out. And you notice how each element that was pulled out, you're sort of adding to a new collection. It'll be a list of objects, as you can see from the method signature there. And so you're going to get an output that's the same values, but it's the order in which soldiers were killed, and in the case of the last person, committed suicide. So our final result is 3627514. They've got links here if you want to read more about the Josephus permutation, though I didn't even follow this link, you don't need it, and a related Kata Josephus survivor, which I have not done yet. So I think that description's pretty clear. They gave a nice example here that was big enough to see this thing in action. What you should do now is pause the video, give this an honest attempt, and come on back to me when you're ready. I'll start setting this up, and then I'll go into my solution. Now, before I do show you my solution, because this is a learning channel, I want to show you how to take a real-life situation and model it using object-oriented programming. So you could just, certainly when we submit this, we're going to see ways to do this without creating classes and objects and making objects that interact. You could do this with just some logic, but again, this is instructional. I want to show you how, because this is why we do object-oriented programming. You have a real-life situation, and we're going to model it in software using objects that are defined. We know how they behave. So to that end, I'm going to make a couple classes, and it looks like these aren't aligned properly, so there we go. I'm going to have this idea, the way I read this story, right? They all formed into a circle, and we have soldiers. So I'm going to make a circle class and a soldier class, with the idea being that I can convert each of these objects in the input into a soldier. And before I get ahead of myself, I should show you in the tests, please note that they're not always integers. They have some strings in this case. Maybe it's just integers and strings. I don't know. When we get to the attempt, I don't recall. But that's why they're objects here and not integers, so they can put anything they want in them. So just keep that in mind when you're solving. Anyway, I'm going to create, I want this concept of a circle that consists of soldiers, right? I'm going to pretend like the soldiers are in a circle, and then it'll be some kind of, the circle will have a behavior that I can invoke that sort of kicks off this Josephus permutation, if you will. So let's do that. I'm going to make a couple classes. Private class. I'm just including them right inside Josephus. See the scope here? These two curly braces. I'm putting my private class inside. If I needed to use my classes outside of this scope, the Josephus class, I would list them down here. And you can do it that way if you prefer to. I'm just showing you can You can embed classes within classes. So let's have a circle class, and then we're going to have a soldier class. I'll probably start with the soldier class. It's pretty simple. It's going to be mostly a data thing. So I'm going to make a constructor that gives us a way to create soldier objects. And for that, soldiers, I'm going to have two properties, right? From the input, they give us some kind of data that represents the soldier. I like to think of it as an ID, something that identifies the soldier. So I'll name mine that way. Let me go ahead and start setting up these fields. I'm actually going to make them as properties. So I'll say public object ID, and I'm just going to use getters and setters here. These are properties when you see this. If you recall, I have, normally we're used to seeing it like this when you make a field, but when I put these curly braces and define a getter and setter, it's what we call in C# a property. Then I'm going to have another property called, it's a Boolean, so I like to name my Booleans like this, where it sort of answers a yes or no kind of thing. Is alive, I'll call it. Again, I'll make it get, and I'm going to actually make my setters private, meaning just the class itself can modify that data. So, because I shouldn't need to change its ID. Actually, though, I will need to change is alive, because when I initiate the circle move, it's going to kill off soldiers, so I do want to be able to set this outside of the soldier class. So I'm going to remove the private there, meaning other classes, anyone who makes soldiers can change the status of is alive or not. So good. In that case, then I will need a constructor here. We'll say object ID and Boolean alive. And then the idea is once we have that, we could simply set our fields. ID equals ID and is alive equals alive. Okay, so pretty simple, right? A soldier, it's a simple concept. And another point I want to get across to you is when we make objects like this, we model this in software. Notice I'm not putting a weapon on my soldier or his height or how much he can bench press, right? We want to keep our objects limited to the data that's actually relevant to working with them. Now, if I had a game where it mattered what type of weapon a soldier had, absolutely I'd make more fields that have that data, but I'm not putting extra stuff in here that I'm not going to use, and you shouldn't do that either, okay? We want to keep everything as simple as possible. So good, I have some soldiers. Now I'm going to flesh out this circle class. Again, our constructors will make public. You just use the name of your class, and then any relevant parameters as necessary. For my circle then, I'm going to need the sort of the IDs of the soldiers, right? That comes right from our input here. And I also want to store the count, the Josephus count that we're using here. So I'm going to make a couple variables for that. I think I can make them private because I don't think anything outside of my circle class will need to access it. So let's make a list of soldiers, right? A circle is going to consist of a list of, or I should say a collection in general of soldiers. In my particular implementation, I'm choosing to stay with the list collection, which is fine. You could use a different collection if you wanted to. So list of soldier, I'll call it soldiers. And then we wanted to store a count as well. So I'm going to call mine count. And then in my constructor here, we're going to take a list of object. I'm going to just copy the signature of my the input to the original method here, right? In fact, I could have just copied it, but that's fine. I named it soldiers, right? Because I'm in the context of a circle, what I'm calling it. So, it's just little things. You could just call this objects or items, but it's kind of nondescript, right? So every little bit you could do to help yourself, do it. And then I'll call it count. And then I'm actually going to make a body here to show you how to populate this. So clearly we have to do some kind of conversion, right? We have a list of objects, but we want a list of soldiers. And let me capitalize this. I already noticed I did that wrong. So good, we're referring to this class here. So there's a couple ways you could do this. You could loop over the var obj, well, let's use meaningful names, var soldier in soldiers, right? You could say soldiers add new soldier and the information it needs, which would be soldier and alive. So everyone's going to be alive to start, right? So I'm just hard coding true in there. So you could do something like this, or if you want to do the length thing, we could say soldiers equals soldiers, the input passed in. I know it sounds weird when I say it. This is underscore soldiers, our private field here. This is the parameter passed in, soldiers. And then you could say select, right? We know that transforms, it projects the elements of a sequence into a new form. So you could say something like this. I'll call my parameter soldier. I could say new soldier. True, same thing. This is just, I'm just showing you two different ways. You got tomato, you got tomato, right? You got both of them there. Just pick one that you like. Okay, and then we also want to sort of store this count value. We're going to want to refer to it because as I implement the circle, I'm going to decrement a local count value. And then once I choose the soldier to execute, then I will reset the count to the original K value. You'll see that as I implement the method. We're going to give the class circle a behavior. Notice right now it just has data, right? It has a list of soldiers that form into the circle, and then it's got that K count for me. But I want to give it a function, a behavior that once I make one of these circle objects up here, I can sort of initiate this process. So to do that, I'm going to make the method public because I want to call it from outside of the circle, wherever I create the circle. So I could say public, and then our method, we should return for that. What should I call this method? I guess I'll call it commit suicide. That's kind of dark, right? But that's sort of the nature of the challenge. You could name it something else if you prefer. And so again, back to the point of our classes, how we keep them very simple. And I did it again. I forgot to expand. Let me expand a bit for you. We want to keep them very simple. So in my case, when someone makes a circle class, you know you can't mess with any of these private fields. But you just look at it, right? And, oh, okay, I got a constructor here. And then there's one public method, right? It's really obvious what you're supposed to do with a circle, right? So if you can keep your classes small like that, it's really nice when you or other people have to use them and they don't have to read through 100 methods and figure out when to call them and which ones you should call and which ones you shouldn't, which ones are going to mess things up if you don't call them at the right time. So try to keep things small and simple in general. It's good practice. So anyways, back to this main method that's going to handle all of the sort of work of this whole thing, right? Everything else I did was kind of trivial. We made this real simple soldier class, but now we need to do the actual work where we go through and get the final result that they're looking for. So let's make a list object right off the top, what we're going to have to return. I'll call it kill order. Because technically they're not all suicides, are they? They're sort of people killing even if they're friendly soldiers, and then the last person would be a suicide. We'll say new list object. So we got that ready, it's initialized, and it's ready for use when we do that. That's good. So now I'm going to have a couple other properties. I want a local variable to track the index of the current soldier that I'm on. You can imagine I'm going to step through the collection one by one and count these off. And then I'm going to have a count as well. So let's do this. This would be like a soldier index. And I'm going to make it 0 to start because I want to start at the beginning of the list. And then I'll have count, which I'm going to initialize to underscore count. It's that property, it's that saved value. And I'm doing that because I want to decrement this by 1 each time through a loop to sort of count off soldiers until I get to the next one. Remember, there's probably more efficient ways of doing this, but I'm trying to show you how to take a real life situation that either you already know from your own life experience or someone provided to you as a specification, and how you can convert it into a software, something that's modeled by software. So that's the idea here. So we got that, and then let's go ahead and make a variable to store the current soldier that we're on. I'll call it soldier, and that will start at the beginning of our list. You could also just put 0 in there if you want. Index is equal to 0 at this point, so that's fine. Now we're going to make a while loop, and we're going to think about what we want to do here, what the description was in the beginning. We start at the beginning. I know it's a circle, right? But start with the first value in the list. And we're going to count off one by one. And what are we doing? Like, think about this. I'm going to use a while loop. And we know with while loops, we don't want them to run forever. So you have to think of your terminating conditions, right? So I'm going to keep doing this process while any soldier is alive, right? The process doesn't technically end until all the soldiers have died. I know they said in the beginning that Josephus didn't follow through with it, but they're asking us to model the case where everybody is killed. So how can we express that in code? You could say soldiers any, right? Any is a link method, if you recall, that returns a Boolean. And we're just going to see if any of the elements in soldiers meet some condition. Well, what would that condition be? It would be while any of them are still alive, right, is what we're trying to express in code. So hopefully you could appreciate what I set up here. I'm going to add my lambda. There's only a single parameter, so I don't have to put it in parentheses. I'm going to call it soldier, which is a fitting name for any one of the soldiers collection. And then look what we did here. We made this is alive property. So I could say soldier is alive. Do you see how when you are good with your names, you almost get something like maybe someone off the street wouldn't understand this, but someone like you or me who knows, or even people who don't really know code, they can kind of look at this and go, oh, I see what you're saying, soldiers, whilst any soldier is alive. You know what I mean? You can, even if you don't understand what lambdas are, you can kind of get a feel for it. And certainly if you know something about code, it's very easy on the eyes. So that's good. We have one while loop where we're just going to keep repeating while any soldier is alive. And then it's our job within this while loop to kill off the soldiers. And then eventually all of their is alive properties will go false. And that's when this while loop will break out, right? So let's go another level. This is where my count gets in. So while we still have soldiers alive, let's make another while loop regarding the count. So we need to count off. I'm going to achieve this by saying while count is greater than 0. And you can imagine we're going to do something like this. We have other processing to do, but we're going to keep stepping down count, which started at a positive value. In real life, you'd probably want to enforce that this is getting set to a positive value, right? Because if you start, you don't want to end up with an infinite loop, but you'll be okay in this challenge. So we need to do something like this in process. So while the count's not greater than 0. Now, we only want to count soldiers that are alive, right? Because I'm not going to delete anything from my collection. The way I sort of delete is by flipping the is alive property to false. So you can imagine as we are going through this over and over again, we're stepping through soldiers one by one, but at some point we're going to be encountering ones that aren't alive anymore. And we don't want to count those off, right? Because you don't kill them twice. So what I'm going to do to handle that, I'll say if soldier, remember that was the value we set here, and it's going to get updated. If soldier is alive, ooh, not caps, is alive, then we want to count. So let's make a scope for this. Then you can count him off. Don't count him if he's not alive. And then I'll make one case to get out of here for when count is done with. So I could say if, oh, don't need two ifs. If count equals 0, I'm just going to say break out of this while loop. It means we got our, you know, in the example they gave us 3, the count was 3, but it could be 7 or 10 or whatever. But it meant that we counted enough alive ones to get to the soldier that we need to axe next. And so break out of this while loop. So then we'll know that we're currently set to the soldier. So then what we can do next is you could say soldier is alive equals false. This is how we kill the soldier, right? So that's good. Don't forget, we need to add the kill order. Remember that returned collection is going to sort of pick these off one at a time. So this is where I use the soldier's ID for that. We left it as an object because it might not be a number. It could be anything that is an object, which is anything. And so we start building up that output, and then don't forget to reset your count, right? Because it went down to 0 as you were counting off alive soldiers. And then one other bit in here, we need to increment either way, right? So we got to make sure soldiers getting updated. Even if it's not counted because a soldier's not alive, to get to the next iteration, right, we still want to jump over to the next soldier. So we got to keep updating this. We could say soldier equals soldiers, and then we want to increment the index, plus index, that's the prefix operator. That means increment index by 1 immediately before processing anything else. And then I'm going to do modulo soldiers.count. Remember, soldiers is a list, and it has a count property. Again, I don't like that some collections have a length and some have a count. That's very unfortunate. But this is the mechanism we use in 5 Caillou. You should probably know this by now, to wrap around to start counting from 0 again. Because remember, if we don't use modulo the count, then index will just keep going up, and eventually it's going to overrun the size of the soldiers collection. So just a friendly reminder, that's why we do that. And this is a really common mechanism you'll see a lot for sort of wrapping values around to the beginning. So good. So right, regardless of whether the current soldier is alive or not, we still need to go on to the next soldier. We just basically don't increment our count if it's not alive, but you still go to the next soldier. I hope that's clear. And then, yeah, when we got there, we killed them. We added the ID to the order that we need to output, and we reset the count, so we're ready for another one. And then, as you can imagine, once you've done all this, it's just a matter of returning the kill order. And that looks good for our circle class. And then the idea is once we've sort of built up these little objects that we have, now we get to play Legos, so to speak. We get to go to the original method and sort of build something with our objects and model this real life scenario. So to do that, I'll go back up to the top, and basically this thing becomes pretty trivial, right? We could say circle, you could call it a Josephus circle or just circle equals new circle, and what were the parameters that our circle class took? It was the soldiers and the count. It was just precisely whatever we were given. So I'll just say items and K. And if you want to rename these to be something meaningful, you're not stuck with these parameter names. So go ahead and do that. And then what do you do with the circle to kick off the process, right? This goes back to that point I made. Well, I don't know. Let's go check circle. There's a constructor. It's got one method you can call. That's it, right? So pretty darn simple. It doesn't get easier than that. Circle, commit suicide, and that took no parameters. So yeah, because it got all the data it needed from the constructor. I think we're fine there. Let me do that. And notice that commit suicide returns the exact data we need, so you can actually just say return that whole thing. So something like this, let's see, did I use link? Yeah, I think I did right here, so I'm probably going to have to bring in using system link. It's okay if you want to run it and wait till you get yelled at. I'm going to minimize out so I can get back and run this. Let's see what kind of typing mistakes I've made that you guys have been screaming at me for 10 minutes. Okay, warning, Phil Josephus soldiers is never signed to and will always have a default value of null on number 53. What do we have here? Okay, so I didn't instantiate it. I should have done that. Let's see where we want to do that. We could say, should I do that? I guess I'll just do it right where it is declared. How about that? So soldiers equals new list of soldier. This is a common thing when you forget to do this, you know what I mean? You just kind of declare it and you never actually created a new object, so it's not ready for use. Let's see if that fixes our problem. Okay, so we hit a problem with index out of range. Must be non-negative and less than the size of the collection. Absolutely for the parameter index out of range. I did something wrong here. Let me see if I can figure out what I did. It was with index. Soldiers plus index. Dex equals 0 seems okay. Let's see. Index 0. I might add a debug statement if I can't immediately see this. Modulo soldiers.count. Yeah, I'm not equals soldiers. That looks okay. Console right line index test 5 index is out of range. Oh, you know what? Test 5. Look at this. Yeah, I should have just went to look at it. Test 5 down here. Look at this. We got nothing in here. They gave us an empty list. So yeah, even 0's an invalid index. So yeah, it really goes to show you the importance of that error checking. So let's see, how can I get around this? You know what? I might just put a trivial check right at the top. Let's do this. Let's say right up here, we'll say if items.count equals 0, just return items. Because if we look at that test 5, it was expecting back just an empty object array there. So let's go ahead and try something like this. There we go. It's that money color, right? And bam, we just nailed it. So yeah, we're going to see simpler solutions. I'm very sure of it when we submit. On a quick recap, I'm going to get rid of some of these things. If you wanted to see the link method too in action, I'll go ahead and, since I'm going to modify the code anyway, just so you can believe me. Same difference again. We just do a check, make sure we even have items. If we don't, there's no sense in doing these complicated processing. Just return. And so look at how easy this was. Just beautiful, right? We just make a circle and then call the one public method it had, right? It's pretty hard to use this thing incorrectly, which is what you want out of software. The circle class, we modeled that Josephus circle where it took the soldiers and their identifiers, a certain count value that could be variable. We made that collection of soldiers, our circle, and then we had this method to kick off the whole process. We got some local state variables here to help us through the looping. We process while any soldier is alive. We start counting them off per the count. And then, yeah, keep incrementing the soldier each time till you get to a live one. You've counted off the right number of live ones. And then when you get to that one, that unfortunate soldier, you go ahead and axe them, reset your count for the next sort of iteration. And then soldier was really easy, right? Just an ID and a thing if it was alive or not. So yeah, pretty simple here. Really the point, I'm gonna get rid of this print statement. The point was to model, show you how to model a scenario. That's what I was really trying to sell you here. Don't be afraid to create lots of classes, lots of little classes that are easy to use, and then you play Legos with them. That's the idea here. So I'll get out of here. They're gonna make me attempt again. Uh-oh, I messed something up. Soldier to... Oh, I think I know what I did. On that link call, where was it? This one right here, right? We use select. Do you remember what select returns? It returns an I enumerable collection, and soldiers we defined as a list. So don't forget to put the extra to list call there if you want to use this version. The for loop was fine before, but I just figured I'd show you another way. So yeah, I like what I have here. I'm going to send it off this way. And then see what I mean? You didn't need to create any classes. These people were able to just write some simple logic to do this. My goal, again, was to show you how to model real life scenarios in software, sort of the essence of object-oriented programming. But yeah, lots of people doing it sort of the same way here. Let's see if anyone else did something different besides me. Or if I made the Wall of Fame, come on. No love for Shug. That's all right. But yeah, feel free to look through these as you like. Otherwise, you know where to find me with questions and comments. I appreciate you watching the videos. I hope you're getting a lot out of them. And I really appreciate those comments. So keep dropping me comments if you have them. Even say something nice, something critical. It's all welcome. I will see you in another video. Thank you.